In this demonstration, I'll show you how to approximate the area of a function using midpoints. Sometimes it is difficult to use the Riemann sums, as demonstrated in one of our previous videos, to evaluate the definite integral, so we settle for approximations. The midpoint rule is defined below. Now, to understand the midpoint rule, let's take a look at the first question. Here we're asked to use the midpoint rule to find the approximation to the integral between 1 and 2 for the function 1 over x to the power of 3 plus 1 using n is equal to 4. Essentially what they're asking us is, using 4 rectangles and their midpoints approximating the curve, find the area of those 4 rectangles. And the way we would do this is we would start off by finding out the difference of x. So the difference of x is equal to 2 minus 1, and that is equal to 1. Now, also keep in mind that we divide it by 4 because we have to use 4 rectangles now, which is equal to a quarter. The next thing that I'll do is create a number line between 1 and 2. And I will separate this number line in quarters. So our first interval will be 1.25. All I did was add a quarter to 1, and then I'll add a quarter to this, and another quarter to this. And at the same time, what I'm going to do is find the midpoints of each. And the way I would do that is find the difference between these two, these two, these two, and these two. Let me demonstrate what I mean. So if I were to take 1.25 and subtract it by 1, and then divide by 2, because it's the midpoints in between, I would end up with 1.125. Now similarly, if I were to do the same thing in between these, I would end up with 1.375. And in between these, I would end up with 1.625. And in between these two, I would end up with 1.875. Now, just to keep in mind, what I did was I took 2 minus 1.75, subtracted them, and then divided by 2. The next thing that you'll do is set up your function the way that it is shown here. So we have the integral between 1 and 2 for the function 1 over x to the power of 3 plus 1 dx. And another way to write this is by finding the sum of f at the average of x, the difference of x. So that being said, what we can do is replace everything that we know. We know the difference of x is equal to a quarter. This right here represents your x. We can find the difference for our function like this. 1 over x to the power of 3, which we're not going to use x to the power of 3. Rather, we're going to use 1.125 to the power of 3 plus 1. And then we're going to keep adding each of those midpoints. And then finally, 1 over 1.875 to the power of 3 plus 1. With that said, we can compute this with our calculator, and at the end, don't forget, I'm just going to make some space here, don't forget your difference of 1 over 4. This represents your delta x. Now that we have this, we can use our calculator to compute the following, and you should end up with a total of 0.2527. And that number right there approximates the area underneath this curve between 1 and 2. So there you have it. That is how to approximate the area of a function using midpoints. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.